To distinguish between galvanic cell, also known as voltaic cell, and electrolytic cell, there are basically 5 differences I want you to remember. One is in voltaic cell, in order to make a wet cell or a wet battery, the reaction has to be spontaneous, meaning your E cell should be greater than 0. And also you should remember in that case delta G has to be negative, and we put a negative sign times moles of electrons traveled times your E cell times a constant known as Faraday's. We are not going to worry about the equation, but just remember E cell positive and delta G in that case negative. In electrolytic cell, the reaction is non-spontaneous. So that's a major difference. The reaction does not take place on its own. So E cell is less than 0. The second main difference is in voltaic cell we use chemicals to produce electricity, but in electrolytic cell on the other hand we use electricity to produce chemicals. Now these chemicals usually are extremely reactive and we want them to be pure or as elemental. So we use electricity to produce chemicals. Now anode and cathode are the same definition in both cases except their signs. Anode is always site of oxidation, except in a battery, in a voltaic cell, it's negative because you simply produce electrons on it. And in that case, cathode, the other site, which is site of reduction, becomes positive. Now, the same definition goes for anode and cathode in electrolytic cell. Anode, you should remember it, is always site of oxidation, except in this case, this is positive sign. Why? Because it's attracting or attracts anions, which are negative ions or non-metallic ions. Cathode, on the other hand, in electrolytic cell, it's still site of reduction, but its sign is negative, and you can remember it as it's going to attract cations, and cations are positive and they get attracted to negative pole, attracts cations, which are positive ions. The last distinction is in a battery voltaic cell, you always have 2 half cells represented usually by 2 beakers connected by a salt bridge. Now salt bridge connects the entire electric circuit, also compensates for loss and gain of electrons. Then you have 2 electrodes that are soaked into their own electrolyte, connected via a copper wire external circuit to a voltmeter or a light bulb. This is usually your battery. Now in electrolytic cell, you only have 1 beaker, 1 cell. And then you have 2 inert electrodes, usually graphite or platinum. And then you have your molten or aqueous solution, and you connect it to positive pole of battery shown like this, and a negative pole, which is a smaller line, connected to the electrodes. And we worry about molten and aqueous in the next slide.